are the list of 35 borrowers of sample that we randomly select.
For point number 3, data presentation, we have to select a qualitative data, which is country, and construct it into a frequency table, and then a bar graph and a pie chart. So, when we construct a frequency table, we can see that the frequency in country United States is 9, and United Kingdom is 2, and Malaysia has the highest, which is 24. To summarize it, we can see that the Mara loan borrowers in Malaysia is the highest, which is 24 out of 35 samples, and the lowest is United Kingdom, which is 2, and the middle is United States, which is 9.
The bar graph illustrates the number of people who borrow study loan from Majlis Amanah Rakyat, which is MARA, and the countries they are studying in. Malaysia holds majority of borrowers with 24 people, while United States came in second with 9 borrowers, and only 2 borrowers are studying in United Kingdom.
Assalamualaikum, my name is Nur Syahirah, and I'll be presenting the next slide, which is the pie chart that shows the percentage of 35 people who borrow study loans from Majlis Amanah Rakyat MARA from 3 different countries: Malaysia, United States, and United Kingdom. As it is shown on the graph, most people are studying in Malaysia with 68.57%, and coming the second is the United States with 25.71%, and only a minority of people are studying in the United Kingdom with 5.71%.
For B, quantitative data presentation, which we choose age as the quantitative variable, then we have to construct a group frequency table. To make a group frequency table, we need to know 2 things. First is the number of class interval, and the second is the class size, or we call it as class width. Then we will put our information inside the formula. The formula is K is equal to 1 plus 3.3 times log n base 10. So we will put n, which is 35, inside the formula. So it will be 1 plus 3.3 times log 35 base 10. From that, we got that K is 6.09. But we will round it as equal to 6. And for class width formula, which is L, it is the maximum value in the data minus the minimum value in the data over the number of class interval K, which we got before. So the formula will be 30 minus 19 over 6.09, or 6. So we will got the class width L as 1.83, and I will round it as 2. So from both formula, we got that the number of class interval is 6 and the class width is 2.
This distribution skewed to the right, and it is positively skewed. This kind of distribution that may occurrences in the lower value cells, which is in the left side, and few in the upper value cells in the right side.
The third, which is frequency icon. As you can see from our frequency, there are 3 times. So the frequency table will look like the graph with the summary, and the summarization of it is the tail of the polygon that stands further on the left side, which is known as skewed to the left or negatively skewed.
The next slide is the cumulative frequency table, or known as OGIF. In this graph, the vertical axis represent cumulative frequency, meanwhile the horizontal axis represent class boundaries. So we mark the points intersection of the class boundaries and the cumulative frequency. Cumulative frequencies are defined as the sum of all the previous sequences up to the current point.
For mean calculation, on average, the age of list of borrowers who applied for study loans at Majlis Amanah Rakyat, which is MARA, is 24.75. For mode, the most common age of list of borrowers who applied for study loans at Majlis Amanah Rakyat, which is MARA, is between 25 until 26.
The next slide is the calculation for median. First, we need to find the location, and to find the location, we need to take the number of sample plus 1 and divide it by 2. So our sample is 35 plus 1, we get 36, and divided by 2, we got 18. So the location is at the 18th place. Now that we got the location, we can start calculating the median. So we find the lower boundaries for the 18th location, which is 24.5, plus the number of sample, which is 35, divided by 2, plus the cumulative frequency of the class before the median class, which is 15, and divided by frequency of median class, which is 8, and multiply with the class width, which is 2, and you'll get the total of 25.13.
Quartiles. In calculating quartiles, first we should know the location and then we can calculate the quartiles. So to find the location of first quartiles, we will use the formula location is equal to n plus 1 over 4. Our n, which is 35, put it into the formula so that it will be 35 plus 1 over 4, which we got as 9. To know where the quartile class is, we should check in the group frequency table for frequency and cumulative frequency that have 9 in between it. So when we look at the group frequency table, we can see that 9 lies between frequency 5 and cumulative frequency 10 in the second class interval, which is 21-22. So all that is considered as the first quartile class. And then we will go through the quartiles formula as shown beside me. So we will put the information inside the formula. So 20 plus 20.5 plus in the bracket 55 over 4 minus 5 over 5, and we will times it with 2, and the final answer that we will get is 22. So the interpretation is 25% of the MARA study loan borrowers age less than 22, and 75% of the MARA study loan borrowers are more than 27 years old. For the third quartile, the formula is quite similar, but there is a big differences in it. So for the location, we will put 3 outside and times with f plus 1 over 4. And then we will put it into the formula 3 times 35 plus 1 over 4. And then we will get the location 27. And when we look at the group frequency table, we could see that 27 lies between the frequency 7 and cumulative frequency 30, which is in class interval 27 to 28. So all of that is considered the third quartile class. And then I will show you the formula of the third quartile with me, and we will put our information inside the formula. So 26.5, which is lower boundaries of third quartile class, plus by 3 times 35 over 4 minus 23 over 7 times with 2, and 26.5 plus 0.92, which is equal to 27.42. From that, we got to know that 75% of MARA study loan borrowers age more than 27 years old, and 25% of MARA study loan borrowers age less than 22. The distribution has a slight skew to the left, which is I get from the calculations of the skewness and the calculations of the mean, mode, and median. So when the distribution is distributed slightly to the left, it is also known as a negatively skewed, which means the mode is the highest followed by the median, and the lowest, which is the standard deviation. There is the formula, which is for n lower than 30 and n is equal or bigger than 30. So in this case, the our n is 35, which is bigger and equal to 35. So we will use the second formula. Okay, the formula will be s is equal to square root total fx squared over total f minus, in a bracket, total fx, close the bracket, and squared outside bracket, over total f squared. And then we will put our information from the group frequency table into the formula. So f is equal to square root 21,820.72 over 35 minus 866.5 squared over 35 squared. And then s is equal to square root x 623.449 minus 612.916. And then we will get the standard deviation as 3.25. Application of the standard deviation will be about 68% of age among study laborers at Mara lies between 22 and 28.
For Pearson measure of skewness, we have two calculations, and both of them is skewed to the left since it has a negative value, which is the first one we have negative 0.38, while the second one we have negative 0.35.
The next slide is calculating the coefficient of variation. We need to take the sample of standard deviation divided by the sample mean and multiply by 100%. So our coefficient of variation is 3.25 and our mean is 24.75. Multiply by 100 and we'll get 13.13%. Next slide is comparing the consistency with our fellow group assignments. So based on the calculated standard deviation, it shows that the ages for CVA is more variable because of standard deviation A is 3.25, which is bigger than standard deviation B, which is 2.88. The mean ages for CVA are slightly different to the mean ages for CVB. Therefore, we need to calculate coefficient of variation. So from the calculated CV, it is confirmed that the ages for CVA is more variable than the ages for CVB, since CVA equals to 13.13% and CVB equals to 11.85%.